Now we're going to look at how we can use this technique called plugging in for a specific type of question, specifically integer property questions. So remember, an integer is a positive or negative whole number, and there are different properties of integers, like being positive, negative, or zero, whether one is divisible by another, whether one is a multiple of another, if an integer is prime. So we have different integer properties that we can learn about. There are some lessons on those that you're welcome to go and review if you need some refreshing on those. But there are plenty of different ways that integer property questions can be asked on the exam, and in a lot of those cases we can use plugging in. So this is going to give us some examples of that. Now when we plug in, we need to choose our own number. So let's talk about how to choose numbers wisely. We want to choose numbers that are simple, that are going to be easy for us to work with. It's very important that if the problem gives us any specific conditions or rules, that we meet those conditions. And other than that, we want to choose numbers that will be easiest for us to work with. Some people like to use this list as a foundation for what numbers to choose. So obviously, small whole numbers like 0, 1, and 2, really easy to work with. Sometimes we need negatives, so we can keep the negative versions of those. Sometimes we need a fraction, so a really good place to start might be something like 1/2. But this is a good sized list. Why? Well, it's possible that plugging in a number could lead to having more than one answer choice work out. And if that happens, we're just going to pick another number and try again. Not a big deal. Another reason is that there could be multiple variables in a problem, and when that happens, we want to choose a different number for each variable. So this is a good starting list that a lot of people like to keep in mind when they're picking numbers. And as you practice different plugging in questions, you can also pay attention to numbers that you enjoy using and sort of build your own personal list. So the first kind of integer property problem we're going to look at is a must be problem. So this is going to include that phrase must be somewhere in the wording. And what we want to do is look at all the answer choices, and for each one we're going to try to disprove that answer choice, to prove that it is not whatever it must be. And then the one that is left when we've done all that, that's going to be the right answer. So we want to eliminate all the answers but one. Here's an example. Notice the wording. If k is an odd integer, which of the following must be an even integer? And we definitely have integer properties here because we have odd, we have even, we even had the word integer. So we have one variable k. We need to pick a value for k. And k has to be an odd integer. If we do not use an odd integer for k, we're going to get the wrong answer. So what is the simplest, easiest, most pleasant odd integer in the whole world? Most people would agree. K equals 1. We're going to plug that into each of the answer choices. Let's get started. A. K squared minus 4, plug in 1, 1 squared minus 4, 1 minus 4 is negative 3. What do we need? We need must be an even integer. Is negative 3 an even integer? No, it is not. On your scratch paper, I recommend writing down letters A, B, C, D, and E. Since we want to eliminate 4, every time we get one wrong or one eliminated, we cross it off. B, 3k plus 2, 3 times 1 plus 2. 3 plus 2 is 5. Is that an even integer? No. Cross off B on your scratch paper. C, 2k plus 1. 2 times 1 plus 1. 2 plus 1 is 3. Nope, not an even integer. See how quickly we're able to eliminate most of these answer choices because we chose a simple, easy number to work with. D is going to give us 12k over 8, so 12 times 1 over 8. 12 over 8? That's not even an integer, so it doesn't matter whether it's even. That's not an integer. So when we cross out D, we're very hopeful for E because that's the only option remaining. Let's check it out. 6k over 3, 6 times 1 over 3. 6 divided by 3 is 2. Sure enough, that is an even integer, so we select E and we move on. So what did we do here? We tested each answer choice one by one to try to disprove or eliminate the ones that did not meet the must be condition. 4 out of 5 were gone, and the one that remained was the correct answer.